Good morning, everybody. So, in this lecture, we will discuss on problems on hydraulic jump. So, for doing the problems on hydraulic jump, I have taken from the fluid mechanics textbook of R.K. Bansal and then trying to really explain you some of the important problems from it. So, kindly work on those problems because the problems are not just to see and go. Problems are only to just you can see once, but unless you practice, take your calculator and practice as many times as possible because there are not many models. The models are only two, three models. Only thing is if you practice number of problems two, three times, it will be very easy to score. And if you have seen the last two papers also, we have easy questions in this particular unit. Any unit actually, the questions are not difficult. Only thing is, the only my submission to you all is practice, practice, practice. That's the only way to really score maximum marks in this course. Unless you practice, you cannot just read and write the derivation, for example, or the problems. It's the only practice. Take a white paper, derive the equation. I have derived the equation before you without anything. The same way, you also start doing it. Wherever you stuck up, then you can see the my basically the lecture. Otherwise, if you start it, I'm sure that you're bound to be successful. So only thing is in the entire fluid mechanics course, my submission is to you is it's not just a reading thing, it's only doing thing. As many times as you practice, you are going to be highly successful. And I want that and I wish that. With that, let us go straight away into the problems. The first problem topic is hydraulic jump. The problems. A sluice gate discharges water into a horizontal channel rectangle with a velocity of 6 meters per second and depth of flow 0.4 meters. Width of channel is 8 meters. Determine whether a hydraulic jump will occur. First is that whether it will occur. If so, find the height. The height of jump. Height means height of jump and loss of energy. Also determine everything has come now in this problem, one problem itself. Also determine the power lost the power lost in hydraulic jump. So first thing is rectangular channel that you underline. Velocity is given, depth of flow is given, channel width is given. Question is whether hydraulic jump forms or not. If so forms, what is the height? What is the loss? What is the power loss? Key questions actually. So now what is given actually B is equal to 8 meters. V1 is equal to what he has mentioned is equal to 6 meters per second. Then what is Y1? He has given it as zero point 0.4 meters. So this is the thing. So now for anything that we want to do it, how to know whether jump will form or not, whether jump will occur. This is the question. How to know it? If round number of the incoming flow FR1 is greater than 1, then jump forms. Then jump forms. That is the first thing. Then jump forms. If FR1 is less than 1, jump will not form. Round number should be greater than 1, then only jump will form. That is the first thing that you should understand. Now, what I should find out, then find what is FR1, right? That is it. How to find FR1? FR1 is what? FR1 is equal to V1 by root GY1. Because it is rectangular channel, the hydraulic depth is replaced by depth of flow itself. V1 by root GY1. So now what he has given, V1 is given 6. What is G actually? It is 9.81. What the other one, the depth is zero point 0.4. So if you find out what is V by root G by 1, then naturally it is going to be how much actually? It is equal to 3.029. So this is first thing. So that means FR1 is greater than 1. Therefore, hydraulic jump occurs. This is the first answer. That is over. Then what is our second question actually? The second thing he asked, what is the so find height of jump? So height of jump he asked. Second question. This is first question. This is second. Height of jump. Height of jump, how you will get it? Height of jump is nothing but y2 minus y1. Right? Already you know, already y1 is given. So therefore y2 is how much? This is thing. If you find out, then you can find out thing. So how to find out y2? Basically, we are having what is the equation? What is the equation? What is the equation of hydraulic jump in rectangular channels? Equation of hydraulic jump in rectangular channels, that you know it already. It is 2q square by g is equal to basically y1 y2 into y1 plus y2. This is the equation. So now let us find what first. Let us find q. How to find out q? Q is, Q is equal to A1 V1. So then naturally, what is A1 V1? It is BY1 into V1. So then what is Q by B is equal to what? Small q. Small q is equal to what? Y1 V1. So if I substitute that in that, so therefore, what is first Q? V is equal to, he has given 6. And what is Y1? He has given zero point 0.4. So it is equal to 2.4 meter cube per second per meter length. Right? Now substitute it. 2 into q square means 2.4 whole square by 9.81 is equal to y1 is 0.4, y2 into y1 is 0.4 plus y2. This is the thing. So now what you should do, you can expand this. You can expand this and find out what is y2. So if you find out y2, what is the thing that you can get? 1.525 meters. The same answer can be obtained. The same answer can be obtained by another method also. What is that another method? We know basically y2 is equal to y1 by 2 into basically square root of 1 plus 8 f1 square minus 1. So you can use this. So y2 is equal to zero point 0.4 by 2 into square root of 1 plus what is f1 you calculated 3.0298 into 8 into square minus 1. So here also if you calculate it will be 1.525. So whichever method you want you can choose it, we don't mind. Then next, what is the third question? What is loss of energy? What is loss of energy? Before going to loss of energy, so what is the height? Height is equal to y2 minus y1. So y2 is 1.525 minus zero point 0.4. So it is 1.125 meters. So this is what you should remember. The third, second. Loss of energy is equal to equation is what? It is y2 minus y1 whole cube by 4y1 y2. What is y2? 1.525 minus basically zero point 0.4 whole cube by 4 into y1 is y2 is 0.525 into zero point 0.4. If you calculate this, you are going to get 0.5835 kg meter per kg or Newton meter per Newton. Anything is okay. This is what we will get. Then last question he asked is what is power lost? Power lost is equal to gamma Q into HL. Gamma is equal to how much water it is 9810 Newton per meter cube. What is Q? Small q into B. Small q, how much we got it actually already. Small q is nothing but V1 Y1 into B. So V1 is how much actually 6. Y1 is zero point 0.4 into 8. So if you calculate what is this, Q is equal to 19.2 meter cube per second. Then you can apply it. Gamma is HL is equal to how much? 0.5835. So therefore it is 9810 into 19.2 into 0.5835. So how much you are going to get actually? It is going to get 109.9 into 10 to the power of 3 watts. And if you want to convert into kilowatts, it will be equal to 109.9 kilowatts. Anything. So this question, everything is covered. Actually, I will take you to the second question. Second problem. A hydraulic jump forms at the downstream end of spillway carrying 17.93 meter cube per second discharge. If the depth before the jump, terminology please remember, before the jump is 0.80 meters, determine the depth after the jump, and energy loss. All are similar. Only thing is the first question I have covered everything. Now there is nothing to cover actually in all these problems. Q is equal to 17.93 meter cube per second. He has given, and then he has given y1 is equal to zero point 0.8 meters, right? Let us say because now we want small q. So what is the width? Width not given, not given. So assume it as 1 meter only, 1 meter only. So therefore Q is equal to what? The same 17.93 meter cube per second per meter. Right? That we will record it. So therefore now we will do what? What is he asked y2? What is y2? You remember it is y1 by 2 minus y1 by 2 plus square root of y1 squared by 4 plus 2q squared by gy1. That if I take it, so what is y1 is how much? Minus 0.8 by 2 plus square root of zero point 0.8 squared by 4 plus 2 into 17.93 square divided by 9.81 into zero point 0.8. There is nothing, only thing is you need to calculate. Number of times you do number of problems, it will be very easy for you really to do the things, right? Now, if you do it, how much you are going to get? It is minus zero point 0.4 plus if you do all that it will be 9.06, so it will be finally 8.66 meters. Therefore now what is next? Basically if I take it, what he has, energy loss is equal to y2 minus y1 whole cubed by 4y1 y2, simple. So y2 is 8.66 minus y1 is zero point 0.8, both whole cubed divided by 4 into 8.66 into zero point 0.8. If you do it, you are going to get some head loss or energy loss. It is going to be 17.52 meters. So this is the second question. All any problem, once I have done the first problem, all are similar actually. There is absolutely nothing actually. I will do one more also just for your understanding sake to really think. A sluice gate discharges water into a horizontal rectangular channel with a velocity of 10 meters per second and depth of flow 1 meter. Determine the depth of flow after the jump and consequent loss of total head. Loss of total head. That's it. Then again you take it. What is the velocity? 10 meters per second. What is depth of flow? Y1 is equal to 1 meter. And anything is given basically. That's all. So if you take it small, what is small q is equal to v1 by 1. So it is 10 meter cube per second per meter, right? So what he wants actually, what is y2? What is the y2 is equal to minus y1 by 2 plus square root of y1 square by 4 plus 2q square by gy1. That's all. Minus y1 is 1 meter minus 1 by 2 plus square root of 1 by 4 plus 2 into 10 square by 9.81 into 1. So if you do it, what is y2? You're going to get 4.043 meters. Then what is the loss of energy? Or head loss is equal to y2 minus y1 whole cubed by 4y1 by 2. So y2 is 4.043 minus the other one is 1 divided by 4 into 1 into 4.043. If you calculate this, it is going to be 1.74. So these are the problems. I have done three problems basically based on this topic. So that is maximum anybody can ask in hydraulic jump is only this actually. So if you really work on these three problems, it is more than sufficient. That is what I wish to convey to you. So with this, we will stop this lecture also in hydraulic jump. So with this, actually, with this lecture, we have covered the entire, the last topic of open channel flow, that is uniform flow, non-uniform flow, gradually varied flow, rapidly varied flow, everything we have covered. So this kindly prepare all these things after really going through it, do it. So my once again my appeal to all of you is only do the problems, do the derivations. There is nothing to read in this. This is one of the important points. With this, thank you very much for your patient listening and really work hard. And I wish you all success.
Like, share, and subscribe. Hit the bell icon for more updates.